Hello everyone, this is Mel. Today let's go through chapter 2 summary of specialist math, unit 1 and 2 of VCE. Okay, so this is about set and sets of numbers. So natural number, integer, rational number, and real number. Okay, first, set notation. So about set notation, we have element and sets. So the relationship between element of a set, for example, if X is an element of A, then we use this symbol. So X is an element of A, written as this. So if it's not, then we do this, so cross it out. And the universal set. So all element in the set included, so that's called a universal set. And the empty set means no element included. If with the relationship between set and sets, so if set A and set B, if A is a part of B, then we say A is a subset of B. So using this symbol. So between element, we use this. Between sets, we use this. Okay, now if we have two sets A and B, the union of set A and B means consisting all elements that are in either A or B or both. Then what about the intersection? So union is written as this. So if you say union, then that's a U, right? And that's why it's written as this. Okay, it's a good way to remember it. And about intersection, which is the upside down of this one, so written as this. So the intersection means consisting all elements that are in both A and B. So if we draw a Venn diagram, this is A and this is B. So the cross area is the intersection. This is A intersect with B. And all the elements in A and B, that's called the union of A and B. Okay. Complement of A. So A dash. So that means consisting all element belongs to the universal set that are not in A. So if the box represents the universal set, and A is this part, so A prime is this part, the left behind part, this part. Okay. The number of elements in a finite set A. So this actually represents like how many numbers of element do you have. For example, if we have A to be, let's say 1, 2, 3, 4, 6, and that's 5 numbers, so is equal to 5. That's it. Okay, sets of numbers. We have natural number, which is n, integer, which is z, the rational number, q, and the real number, r. Okay. Let's talk about thirds. So what is thirds? A quadratic third is a number of the form like this. For example, we have root 2, root 3, and so on. And A is a rational number, which is not the square of another rational number. Okay, so these are like the quadratic third. For example, this one, we can actually simplify it into 2. So this is not a quadratic third. A third of order n. What does that mean? So it's actually like the root n. So for example, if we have root 3, so this means a third of an order of 3. And also A is a rational number, which is not the perfect nth power. So for example, if we have something like this. This can be again simplified into 2, and that's not a third of 3. So this is not a third of 3. Okay. When the number under the square root has no factors, which are squares of a rational number, the third is said to be simplest form. So how do we actually simplify a third? So for example, we have square root of, let's say 12. This is equal to, we first find the biggest power in 12. So 12 can be written as 3 times 4, right? And 4 is the power of 2. And this can be simplified into times 2 squared. And 2 squared with a root is just 2, and left with root 3. So square root of 12 is equal to 2 times root 3. And this is called the simplest form of a third. And then this dot point says, if thirds which have the same irrational factor are called like thirds. So the sum or the difference of 2 like thirds can be simplified. Look at this formula over here. If we have m times root p plus n times root p, then we can take the root p out, which is m plus n times root p. For example, if we have root 8 plus root 18, then root 8 is 2 root 2 plus 18 is 9 times 2, and root 9 is 3, so 3 root 2. And this is equal to, if we use the formula, we should have 2 plus 3 root 2, and that's 5 root 2. Yeah, so this is what this formula is about. And same with the subtraction. So if we have 8 root 8 minus root 18, and that should be equal to 2 minus 3 root 2, which is negative root 2. Okay, let's move on to natural numbers. The first dot point is about the definition of what is a factor. So if we have a natural number a and a natural number b and a natural number k, if b is equal to a times k, then we say a is a factor of b. So for example, 6 is equal to 3 times 2, then we say 3 is a factor of 6, or we say 2 is a factor of 6, depending on which one do you want to be, a or k. Okay, so the next one, a natural number is greater than 1 is a prime number if its only factors are itself and 1. So for example, if we have 2 as a prime number, because 2 is equal to 2 times 1, which is itself times 1, or 3 is equal to 3 times 1, and 5 is equal to 5 times 1, and 7 and 13. Okay, so these are the prime numbers. Is 6 a prime number? We have 6 factors as 1, 2, 3, and 6. So because 6 can be written as 3 times 2, so this does not satisfy a prime number. So 6 is not a prime number. Okay, so what is a composite number? So a natural number m is a composite number if it can be written as a product of m is equal to a times b. And a and b are the natural number greater than 1 and less than m. So for example, let's say 6 again. So 6 is 3 times 2. 3 is greater than 1, 2 is greater than 1, and they're both less than 6. So 6 is a composite number. Okay? Every composite number can be expressed as a product of powers of prime numbers. This is called prime decomposition. For example, if we have 1,300, it can be written as 2 to the power of 2 times 5 to the power of 2 times 13. So 2, 5, 13 are all prime numbers, and this is called prime decomposition. For example, let's take 52. Can this be prime decomposition? So 52 is equal to 2 times 26, and 26 is 2 times 13. And we can write it as 2 to the power of 2 times 13. 2 and 13 are all prime numbers. So this is also a prime decomposition. The next one, the highest common factor. So what is the highest common factor? It is, so for A and B, the HCF of A and B is the largest natural number that is a factor of both A and B. For example, let's say HCF of 36 and 48. So how do we find the HCF? We can use the following method, 36 and 48. So we first find any factor of both. For example, 6 is a factor of both. So 36 divided by 6 is 6, and 48 divided by 6 is 8. So we first find any common factor of both A and B. So this is A and this is B. And then we're left with 6 and 8. So again, let's find a common factor, which only left with 2, and then 3 and 4. Because 3 and 4 do not have common factor except than 1, so it's the end. Okay, end. And then we times the common factor. 6 times 2 is 12, and 12 is the highest common factor. So the HCF of 36 and 48 is 12. Okay, that's how we find HCF. Then what about the lowest common multiple of A and B? And that means the smallest natural number that is a multiple of both A and B is denoted by LCM. Let's take an example of 12 and 18. So the LCM of 12 and 18, how do we find that? So the first step is we write each number as a product of primes. So it's kind of like the prime decomposition of 12 is equal to 2 to the power 2 times 3. And then 18 is equal to 2 times 3 to the power of 2. Then the second step is take the highest power of each prime. So for the highest power of 2 is 2, then multiply with the highest power of 3 is also 2, power of 2, then it's equal to 4 times 9, which is 36. So the lowest common multiple of 12 and 18 is 36. So you can do it by hand, and it's much more easier if you just type in those commands in your Casio pad or CAS. Okay, that's it for today. This is Mel. Thanks for listening.